Today's lesson is on section 9.4 and 9.5, solving polynomials in factored form. In these two sections, we're beginning to learn the technique of factoring problems so we can solve them. And in particular, it helps more with quadratic equations as we've started to talk about. But just kind of quickly reviewing or bringing it back to the big picture of what we're doing. You used to solve linear equations. Here's a linear equation on the board. Again, problem like this might say solve, and again, what you're trying to do when you solve is find out what x equals to make that equation true. Usually there's only one answer. Sometimes we could have a no solution or an infinitely many solutions as well, but usually there's just one solution. And so to solve linear equations like this, you learn techniques like getting x on one side. So maybe I'd subtract 3x from both sides of the equation to get all my variables to one side of it. So I'd have 7x plus 30 equals 16. And then I'd subtract 30 from both sides, okay? And then I'd get negative 14 equals 7x. And then I knew to do inverse operations and divide by 7 here to get x equals negative 2. And that's my solution, that if I plug it back into this original equation, if I plug negative 2 back in here and here, it'll make the equation true on both sides. Again, things that you learned. You learned techniques to solve those. Now we're learning techniques to solve more complicated equations, quadratic equations. And again, what are quadratic equations? They're any equations where we have x to the second power. Something like x squared plus 2x plus 3, and then equals 0. And again, we'll find out why we want to get it set up like that as we go forward here. Just so you know, answers with quadratic equations actually have a name. They call them roots, because the way we solve them, okay, we do kind of a little different technique than we do when we did with linear equations. You should be taking notes along with me here. And again, here's a definition I'd like you to write down. The roots of a quadratic equation are the solutions to an equation when one side is equal to 0 and the other side is a product of polynomial factors. We probably started looking into this a little bit in the past couple of lessons here, but it's when we try to solve one of these quadratic equations, we get it into something we call factored form by using some of the tools we started to learn by factoring. And then we can tell what values of x will work in this equation to make the solutions. What values will make the equation true? We call those roots. If you're still copying that down, it's up here at the top of the page now. Just want to bring up something that, again, what allows us to solve using this technique, what allows us to solve using and finding the roots of a quadratic equation, is something you learned way back, probably like in chapter 2 or maybe before that, I'm not sure, but something called the zero product property. What it says is if I take two numbers, or any numbers really, any amount of numbers, but if I take numbers and I multiply them together and I know that the product of those numbers is 0, well then either the first number is 0 or the second number is 0. Or if I'm multiplying three things together and they all equal 0, then I know the first one or the second one or the third one's got to equal 0. Like to make that work, if I'm multiplying things together and equal 0, something's got to equal 0 in there. Otherwise that equation can't be true. Well, that is how we find the roots of a quadratic equation. We use this property right here, the zero product property. If I can break a polynomial apart, and so that I just have things that are multiplied together and I can get it all to equal 0 on one side, then I can look at that polynomial, or what I have in the factored form of that polynomial, and say, oh, well, maybe x is this or this, and then I can find my solutions, those numbers that'll make the equation true, so that'll make it 0. So, for example, maybe started looking at these in the past couple days here, but here's two binomials, okay, a polynomial that I've already got in factored form right here, x minus 3 and x plus 4. If I had FOILed this back out, I'd have x squared plus x minus 12 equals 0. So here's what this originally looked like. And as we started to talk about 2, I know when I have x squared, that means I should expect 2 answers for a problem like this. This means it's a quadratic. When I factor it into factored form, here's what that looks like with the two binomials. And now as I look at that, I can figure out some values of x that I could plug in and make this equal to 0. That would make the equation true. Really what I'm doing, just so you know, and as we get in, this will help as we get into more complicated ones. But what you're really doing is you are saying, okay, well, when can this binomial equal 0? What number for x could I plug in to make that one equal 0? Or what number can I plug in to a value for x for that binomial to make this equal to 0? So really, you're kind of breaking this into two little equations. When is this one equal to 0? Or when is this one equal to 0? kind of setting up for those two equations right there. Well, these are like solving these like linear, little one-step linear equations. If I just add 3 to both sides, I get that x is equal to 3. Or if I subtract 4 to both sides in this little equation, I get that x is negative 4. So those are my two answers. But that's really what I'm doing with those two binomials. I'm saying, well, when could this be equal to 0? When can that one be equal to 0? If I solve it like a little linear, just like we know how to do, I can find my two answers. Now, I show it to you that way because in today's assignment, some problems will look kind of like this, where they already have as if the polynomial was factored for you. It's in factored form. I've got it where the two binomials multiplied together give me 0. It's kind of already set up for you to find the solutions. And we've, I think, recently dealt with some simple ones where you can probably just look at it and tell the answer. And even on some of these, you can probably pick out the answer fairly quickly too after a little bit of thinking. But as we get into tougher ones, it will be sometimes tougher to see, oh, what is the solution? What number can I put in for x to make it equal to 0? So here's really, again, what you are doing with these. I've got these two binomials multiplied together to equal 0. 2x plus 18 and 3x minus 18. I am really saying, well, it's like making a little linear equation. I want to know, when does 2x plus 18 equal to 0? Or my other solution is 3x minus 18. When is that equal to 0? That'll give me, solving these two little equations will give me my solutions that I need. So as I go through these, it's like solving a little linear equation. I'm going to minus 18 from both sides. Again, I think it confuses people sometimes when you see the 0 on the one side. Don't let that fool you. Just think of the steps you always do when solving a linear. Inverse operations, right? It says plus 18, so I minus 18. Then I got 2x equals negative 18. Divide both sides by 2, so x equals negative 9. There's one of my solutions. Or x can also equal, again over here, just like solving a little linear, add 18 to both sides, 3x equals 6. If I divide both sides by 3, x equals 2. So my two answers, I could just write simply, x is 2, or 2 and negative 9. Those are my two answers. So to do a couple examples with you, I'd like you to try these two here. Again, like home problems you'll probably see in the homework. In the very near future, we will be factoring a trinomial into getting two binomials like this, like number 7 or like number 8, like I've got up here. And you'll have to do all the work to get them to this part right here where they're in factored form, where I can use the zero product property and solve them. But at this point, today, they do actually just give you some just like this. Again, not quite as easy as some of the ones we've talked about before, where it's just like x minus 3 and x plus 2 equals 0. And I can pick out the answers a little more quickly there with like 3 and negative 2. For these, you know, again, like a little two-step linear. So I have to do maybe just a little bit more thinking. As you're looking at them, in terms of showing work, especially if you're having trouble seeing what the answers are. Again, what you're trying to think of is I'm trying to figure out, when can I make what's in this binomial or this parentheses, when can I make that 0? What value of y can I put in to make that happen? And what value for y can I put in to make it 0 in this binomial? What value of y we'll do it for that one. So again, break them apart almost like two little linear equations. I've got 3y plus 10. When is that equal to 0? And 4y plus 8. When is that equal to 0? And this will give me my two answers. I solve these two little equations. Just like linears. Inverse operation. I'm going to subtract 10 from both sides. So 3y equals negative 10. Divide both sides by 3. So y equals negative 10 over 3. I'm just going to leave it as an improper there. That's fine with me. Or my other answer, subtract 8 from both sides. They cancel out. 4y equals negative 8. Divide both sides by 4. Y equals negative 2. So there are my two answers. Today, when you're going through these ones that are in factored form, okay, if you're picking out the answers pretty easily from them, I'm okay more so if you're not showing as much work. But if you're looking at them and you are having trouble seeing, okay, what actually is the answer? Again, we get some that end up being like fractions like this, okay? Biggest thing is you got to be able to get them right. So if you notice that you're missing them, your partner's not getting the same ones, or the back of the book is not getting the same ones as you, then again, I would bring it off to the side and solve it like a little equation to help. Okay, because on the quiz, when we get to something like that, you've got to be able to get these right as well. If you're able to pick them out just from where they are, that's good, but that still takes a little practice. So this first day, I would recommend showing a little work. Here's number 8, same thing. I need to figure out when each of these binomials equals 0, because that'll make me use the zero product property. That will find the two solutions that make this equation true. So I bring them off just like here. Looks like a little equation. First step in a linear, I would subtract 15 from both sides. I get negative 3k equals negative 15, and then divide both sides by negative 3. So I get k equals 5 as one of my solutions. My other solutions, subtract 7 from both sides, cancels out. I get 2k equals negative 7. Divide both sides by 2. I'm getting k equals negative 7 over 2, that fraction. And I'm fine if you leave it just like that. You can write negative 3.5 if you want, but I don't need you to. It is fine just like that in that form. Then, also in these two sections, we started actually factoring by just learning how to factor out a monomial, or like reverse distribution. Factoring out just one term from maybe 2 terms or 3 terms, whatever it may be, a binomial or trinomial. So for example, I've got some examples right here that I'd like you to do with me as well. 5x squared plus 15x, and the directions say factor. So again, as we've talked about in the past, I can look at the numbers and say, well, I can factor out a 5. And between x squared and x, I can factor out an x as well. And what will I be left with in the parentheses? I'd be left with 5x times, in parentheses, x plus 3. Okay. Well, now, again, going into today, what if instead of it just saying factor, this problem said solve? And this actually was 15x squared plus, or 5x squared plus 15x equals 0. And 14y squared minus 21y equals 0. And same thing for the last one. What if these were all equations and you had to solve them? Well, all that would change is now that once I've done the factoring part, now I got to find my 2 solutions. And again, we know there's 2 because in the original problem, it is the degree 2. So that tells me I should have 2 values for x that work here. So x equals, well, 2 different solutions. Again, look back at the binomial. It says x minus 3. Or sorry, it says x plus 3. So what value for x could I plug in here to make that binomial equal to 0? It'd have to be negative 3, right? That'd be one of our solutions. And then, as I think we've mentioned in a previous lesson as well, if I see an x on the outside of the parentheses, that also gives me my other solution. If I put 0 in here for this x, 0 times whatever's in the binomial would give me 0, right? So that's my other solution when I see a variable on the outside of the parentheses like that. Doesn't matter what number's with it, right? Because any number, doesn't matter what it is, 0 times anything will give me 0, so it'll cancel. But if I see a variable out here, 0 will be one of my solutions. Okay. Again, you should be trying these examples, and I'm walking through them as well, but if you're starting to get it, then you should be doing them too in your notes as something to look back on. This next one, looks like I can factor out a 14y. Oops, actually not a 14y. I can factor out a 7y. 7y out of both terms. So I'll get 2y minus 3 inside the parenthesis for my binomial, and all that equals 0. So now again, I should get 2 answers. Y equals, well, this time I'll start with the one on the outside. Since I got a variable on the outside of the parentheses, that tells me I could put in 0, and that would cancel out everything in this problem. And then now inside the binomial here, I've got 2y minus 3 again. Here's a situation where maybe you want to pull this off to the side for a second and say, when does this little binomial equal 0? Well, I would add 3 to both sides and get 2y equals 3. Divide both sides by 2, and I get y equals 3 over 2, or 1.5, however you want to put it. But that's what I would get for my second answer. I put 3 halves into this equation. It'll make it true. Okay, it'll make that equal to 0, which will make it true. Good, this last one right here. We've talked a little bit about this too. Whenever you see this first term, that leading coefficient is a negative, sometimes it is helpful to factor out a negative in terms of whatever number you do. So like in this case, 16 and 40, I think the GCF is 8, so I'm going to factor out a negative 8 though. And again, down the road you'll see why that can be beneficial as we do more and more of these. So negative 8k I'm going to factor out. That'll leave me with 2k, and then now if I factor out a negative out of this positive 40, it's going to give me negative 5 then, right? To redistribute and get that positive 40, the 2 negatives have to multiply to cancel. So if I factor out negative 8 here, it helps me in this first term, makes it positive, but then it'll make this minus 5. So just a small thing to catch there. Good, I need to know when k will equal 0, or what values for k will make this equal to 0. Again, I've got a variable up front here, so one of them is 0. Okay, equals 0, that'll make this equation true. And inside the binomial, like a little linear, even if you don't need to go through all the steps, even sometimes maybe just setting it up like this and saying 2k minus 5 equals 0. Oh, if I'd add 5, I'd divide by 2. Even that may be enough work just to help you make sure that you get the right fraction and don't have it flip-flopped or have the wrong, whether it's positive or negative. So just something that definitely is helpful on the first day. I would recommend when you're doing these types of problems. Last example I'll go through here quickly, just because on the first day I always get this question because it's the first time we're working with these quadratics and people see new types of problems, they don't know what to do right away. So what if I don't have 0 on one side? I've been showing you a lot of problems where everything's equal to 0, which as you're going to find is the best way for us to solve some of these quadratic equations. But what if I don't have that? Well, simple solution, right? Then just make it so that 0's on one side. In this problem right here, I'd subtract 30x from both sides. That'll cancel it out on the right and move it over to the left side. So I'll get 12x squared minus 30x, and all that equals 0. And now I can do exactly what I was doing in the previous examples. Look for the GCF. In this case, I think it'll be, 6x. So inside the parentheses, I'll have 2x minus 5 equals 0. And then again, for my two solutions then, x equals 0, because I've got an x out here, a variable. And then inside the binomial, I solved that one on the last page. Same thing, 5 over 2, positive 5 over 2 it'll be. So just a little reminder, if you see something like that, don't let it fool you. As we're going to find out, when we're solving quadratic equations, it really helps to have 0 on one side, everything else on the other. So just make it be that way.